Hello, hello. So I just got off a call with Kevin, and uh, I've also been working on this all week. So we finally got good stuff working. Let me show you. Let me show you what we got. So one thing I got working by myself here is Mission Planner. Works on my computer now. Uh, it, I'm basically sending data from a Linux virtual machine to my Windows machine that's running Mission Planner. One thing that I got working is Kevin helped me set up things so that it's working at his kind of level in terms of like the vanilla terrain following using the like fake sonar data. And then I was able to build on top of that to get it to fly normally with the code that I've been working on for the past 3 weeks, basically. So here in Gazebo, we have the quad plane. These runways aren't lined up, but this terrain here, you'll see it in Mission Planner, but it'll actually be using the lidar information pointing down from this quad plane here. And as you can see, everything's flat except for here. We have I think this is a 10-meter high fire station. And our auto mission is just to take off in VTOL takeoff to fly over the station in terrain mode, then to turn around to fly back over this station and turn around and do it over and over again. Basically, we can make it do it twice. And then I am also going to, I guess this is 3 times. It'll start, it'll loop twice, and then it will land. So let's write it to the drone. And so let's also start taking off. So there's some things that Mission Planner for some reason does crash sometimes, but that's just because it's a simulation. So I do use the command line still for a few things. But yeah, so ROS launch, IQSim VTOL test, that's already running. Gazebo's already running. That's this tab. This tab is my Python script. So it's taking the lidar information from Gazebo and sending it to SITL. And then this is extra tab. And then this is SITL right here. So within SITL, it's already turned on. We're going to set it to Q loiter. And then we're going to arm the throttle. Here, let's check on the data. So here you can see Q loiter. You can see these values twitching a little bit. Let's arm throttle. We'll see the rotor spinning up. Then we will give it the throttle. Actually, we don't have to give it the throttle command. We can just set it straight to auto because the first waypoint is auto VTOL takeoff. So auto, let's see if it works. All right, there it goes. It takes off. So far, it's facing the right direction. So things to look at. So even though it says sonar, it's not sonar. It's taking it from Gazebo. Rangefinder 1 is also being read from Gazebo. It's in centimeters. Terrain AGL is the fake terrain data, and this is relative. So now you can see it's dropped a whole bunch. Like this value is much lower, and then the pitch increased. So we'll see that again after it turns on, but it's working. It's kind of quick. It's hard to catch. So basically right now it's maintaining 40 meters above the ground, above this actual Gazebo ground, not terrain. Here it's in a turn. So again, it's going to try to maintain 40. This 40 is going to become 30 meters when it's flying over this police station. And then it's going to climb. You'll see the pitch increases, and then this will also increase up to 40. So now it's 30 meters, pitch is increasing, altitude is increasing. and now it's over. It flew over the fire station, and now the pitch decreased, and now it's flying back at 40 again. So it's hitting that obstacle. It's going up, and then it doesn't quite meet. It doesn't quite get to 40 before it flies over its obstacle, and then it comes back down again. Yeah. So here's the police station again, or the fire station. You see the laser, the bottom laser has to touch the roof. So right now, 30 meters, increasing pitch, climbing. Now it got over the police station. Let's also look at it from the side. So I'm gonna zoom out here in Gazebo. Oh, cool. I'm gonna actually move this in so that it has a little bit longer of a distance to try to get that 40 meters. How about that? Okay. This up here too. It's a bit wider. So there's that bottom reaches 30 meters. It starts to climb. It's climbing. Then that laser hits the ground, and then it starts to dive again. It's so good. It's so good. Let's make Gazebo even bigger. I think I should use this side gazebo view because it's kind of hard to tell when you're following the drone. Came in. Come out, bitch. There, so that bottom lidar hits it, it starts to climb. Then the laser hits the ground and it starts to dive. Sweet. I think it'll do it one more time and then it'll land. Boop, starts climbing. Boop, starts diving. Yeah, now I think it's going into a landing. SITL landing. And tell it to follow the drone. And that's it. That's like a month's work right there. So it took me 1 week to attach the lidars in Gazebo to the drone. It took me like 1.5, 2 weeks to set up the pipeline from Gazebo to ArduPilot. And then this week was spent getting all the ducks in line in terms of getting ArduPilot to react to that data that I was inputting into the drone. Also, another thing that I did this week is last week it didn't interpret it as a rangefinder because it was being intercepted a little bit too late in the process. So I found a different part in the code where I could put it in where it would get interpreted as a sonar, and then it travels through like 4 different CPP files before it gets to altitude.cpp, which is where Kevin's changes are. So my changes are in it's in one of these folders called library. It's in a library folder called AP Rangefinder analog. So it's basically just taking the analog rangefinder that you have, that's like the default fake rangefinder that you have in SITL, and then intercepting that range value and inserting my value with a UDP socket. And then it gets the information from the UDP socket from my Python script. And my Python script is just listening to Gazebo, sending it to SITL, basically. So, feels good. It was a month's work, basically. Maybe like 2 hours a day, roughly. It's gonna land 2-3 hours. Done. All right, that's gonna